Okay, so this is a question from chapter 16 where we're dealing with acid rain and we have an amount of rainfall over an area. We're given a pH and we want to know what is the mass of sulfuric acid present, and we're given that sulfuric acid is the only contribution. Its first ionization is strong, and then it has a second ionization constant, which is actually still fairly large. So what we need to do first, we need to figure out a concentration. We need to find out the molarity of the sulfuric acid. This is going to get a little bit complicated algebraically, but just stick with me. So first thing let's do something we know. We know that a concentration of hydrogen ions is 10 to the negative pH. That's going to be 10 to the negative 3.6. All right. So we get 10 to the negative 3.6. So 2.51 times 10 to the negative 4. That's how much hydrogen we have. So we need to see what molarity of sulfuric acid will give us this final concentration. So it's going to decompose in two steps, H plus and HSO4 minus. Okay, so this we're going to start with, we're just going to call, when we start out, let's ignore this for now because we're going to come back to it, okay? When we start out with this acid, we have no H plus and we don't have any of this. We don't know how much we're starting with. So let's just call this X. All right, now this is a strong acid, so it's going to completely dissociate. So this is going to go away. So that's 0. And then we have X and X. Now, this is now going to lose its own, its second proton. So we need to make another table. So HSO4 minus is going to lose its proton to give you this. Now, we don't know these actual concentrations. That's what we're trying to figure out. So we're solving for X, but it's a little bit different here. Okay, so here we have X, and we have 0. Now, normally we would have X, but we're going to lose another amount here, lose and gain. So let's just call it Y plus Y plus Y. So at the end, we have X minus Y, X plus Y, and Y. We should write our expression for Ka2. So here, Ka2, H plus, SO4 minus 2, and HSO4 minus 1. All right, well, not going to work quite yet. So let's go ahead and plug in our expression though. So we have 0.012 equals X plus Y times Y over X minus Y. Well, with two variables, we're going to need to deal with this. So we know that the total hydrogen ion concentration, which is represented by X plus Y, we know what that is. So we know that X plus Y, we're just forming a system of equations. Think about this sort of like you would do with a partial fraction integration, if you want to. Now, since we're trying to solve for X, which is representing our original concentration of H2SO4, I am going to solve this for Y. So y is going to equal 2.51 times 10 to the minus 4th minus x. So why don't we go ahead and sub that in. X plus 2.51 times 10 to the minus 4 minus x times y, 2.51 times 10 to the minus 4 minus x over x minus 2.51 times 10 to the minus 4 minus x. So let's clear some things out. These x's are going to go away, and then we'll need to distribute here. This is going to get subtracted, and this is going to be added. So let me carry this down. Hopefully you don't mind if I do this and say this times this. I'm just going to say that quantity squared. Minus 2.51 times 10 to the minus 4 times x. And let's divide that by x minus negative x. That's going to be 2x minus 2.51 times 10 to the minus 4. All right. So now, why don't we clear the denominator? 0.012 times 2. So that gives me 0.024x minus 0.012 times 2.51 10 to the minus 4. 3.012 10 to the minus 6 equals 2.51 times 10 to the minus 4. We'll square that. Let's just copy this back. Okay, so now we just need to combine our like terms here. So because I don't like negatives, I'm going to move my x's over to the left and my numbers over to the right. So let's get 2.51 10 to the minus 4 plus 0.024. That gives me 0.024251 x. So now I need to do 2.51 10 to the minus 4. We need to square it. And then we need to add 3.012 10 to the minus 6. So that gives me 3.075 times 10 to the minus 6. Now we just need to divide. Divided by 0.024251. And we get our final concentration of 1.27 times 10 to the negative 4 molar of our sulfuric acid. That was the hard part. It's just some nasty algebra. You won't have anything like this on the test. Remember that molarity is in moles per liter. Now, from here, it's not too bad. It's just some unit conversions, which you know how much I love. All right, so we need to find out how many liters we have. Let's scroll back up and notice we have an area. So this is like an area times a height. So that can give us a volume. So I may run out of room. I'm going to try to write small. We know we have 1 inch, and we know we have 1600, And the way that I do, if you remember my square units, is I just write it twice because I'm really bad at remembering the square, 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 square. So I'm going to convert. I know that I'm going to need to use to get from solid volume to liquid volume, I need to get to milliliters. Or I need to get to centimeters cubed, so then I can go to milliliters. So 1 inch, 2.54 centimeters. That one's done. This is going to take a little bit, and we're going to have to do each one of them twice. Or if you remember the square, you can do that. So 1 mile, 5,280 feet. Do it twice. Okay. Let's go from feet to inches. I love unit conversions. These make me happy. This, not so much. Kind of nasty. All right. Now, 1 inch, 2.54 centimeters. Do it again. My handwriting's really bad. Okay. Now, do you agree we have 1, 2, 3 centimeters? That makes a cubic centimeter. 1 cubic centimeter is the same thing as 1 milliliter. Those are gone. But in order to cancel out molarity here, we know 1,000 milliliters equals 1 liter. We're going to get a whopping number here. So let's see what it is. 1,600 times 2.54, 5,280, 5,280. Watch my button pushing because I might get bad. Okay, so we got 1.05 times 10 to the positive 11th liters. That's a lot. From here, not that hard. We're going to take our molarity. We're going to write it as moles over liters. Plug in our liters that we found. So you could just do this as a single calculation if you wanted to. You could just keep on going. Now, this problem is asking us to find kilograms. So we can get from moles to a mass using molar mass, H2SO4. When you do that on the periodic table, you're going to get something pretty close to 98 grams. Okay, but we don't want grams. We want kilograms. To the negative 4th times 98, and let's divide by 1,000. All right, 1.31 times 10 to the 1, 2, 3, 4, 5, 6. That is a lot of sulfuric acid.